You want to start the recording or
Yeah, all
have it?
set. So just quick intros. I think that you will probably know Chris Cooper for since this recording and these webinars are for Hardware Studio Connection participants. I'm Kata Henning, by the way. I'm with Dragon Innovation. But today we have an awesome opportunity to have Chris walk us through some of the concepts and finer points of electronic hardware design. So without too much further ado, I will kick things off to him. I think he's got some slides to run through. And similar to past formats, once he's kind of run through that part of the presentation, we'll open things to Q&A. I believe you should all see in the bottom of your screen, there's both a Q&A section or a chat section. So please feel free to use either of those, and we'll kind of monitor the questions when we get to that point.
Perfect.
Chris, take it away.
All right, thanks, Kata. So yeah, my name's Chris Cooper. I'm the technology director on the program. So I'm the engineer that tends to look at all the different projects that come through, looking at complexity, how mature the design is, how prepared is a design as it kind of moves from that initial concept all the way through to production. And that's kind of where I'm going to start today, is start the discussion along that path, how it kind of looks, electronic hardware design as we kind of move over. Now, obviously, we're only scratching the design, and I know the topic was very broad, and it was intentionally done that way. We're trying to keep these kind of, especially as we start out with these webinars, try to keep them very broad, and then as we start having discussions with people, we'll begin to narrow them in on very specific topics. So this is kind of intentional, and as you see, as we move through the discussion, we'll kind of zoom in where I see you guys either asking questions or where you have some interest. Okay, but I'll just keep going. And so feel free to, either jump in, like Kata said, on the QA or the chat window, and we'll answer some questions or steer the conversation in that particular direction. Okay. So I'm not going to start here with like Ohm's law or any of those types of things. It's not really centered around, the actual design aspect itself, what an electrical engineer would go through, but more how it pertains to, product design. And what you'd be faced with as you kind of move through your designs and those types of things. All right. So I figured we'd start first with a typical product development timeline, and whether you guys know it or not, this is kind of what you move through. This is kind of our high-level picture that we tend to use at Avnet as we kind of look at what customers move through. And this really doesn't change, a whole lot, as whether it's a creator that's just got an idea and trying to move it into production, or whether it's a big tier 1 type customer that's starting a new product and trying to get it to market. This pretty much looks the same. It's surprising actually how little difference you'll see. Sometimes the timelines might shift if it's a military product or something in healthcare, but other than that, it tends to look pretty much the same. And it all starts out with a requirements definition, and you start to refine it down until you kind of end up with the proof of concept. And the proof of concept is essentially trying to prove that the product will work. And one of the major elements, if you're doing a hardware-based product, is that electronics design at that initial stage, and just to prove that the technology exists and that it's achievable. And then we tend to move towards that prototype, and we tend to get into more of the detailed design at that point. The prototype is meant to essentially illustrate that the look and feel of the product, how it operates. The best way I like to think about a prototype is that a prototype is something that you should be able to hand over to your users, so your target users, and be able to get very detailed feedback on every aspect of the design. So whether it's the look and feel, or whether it's an operational thing, or really, it could even be the color or anything, right? So you want to try to get the product to as final as possible so that you're able to get as much, useful feedback as possible. And then the final is essentially incorporating a lot of that feedback into a product. And then the other big aspect of that final is now you're starting to think about production. So in this final product, that's where you tend to spend most of your time, or you should be. Now, here I'm only showing one prototype phase. Typically, there's multiple in there. This is just to simplify it. In between that proof of concept and prototype can be very iterative. You could also end up with, another cycle between the prototype and final. So it really depends on the product, its complexity, and basically what your development cycle looks like. So there's nothing wrong with having multiple prototype cycles, but you don't want to spend too much time in there because prototyping costs money and time. So that's your trade-off. Okay, so let's kind of, just to kind of start to take the discussion down a particular path, let's kind of focus in on all three of these. And I think it's going to pick up a theme that I talk a lot about with creators. So I just wanted to make sure, in case somebody's brand new to this, I think we're pretty good here looking at the attendees, but if somebody's watching this video that's not very familiar with it, I did kind of want to just take a quick step back. And what are we talking about when we talk about, an electronic hardware design? Really, it's any product that's going to incorporate some type of electronics, which essentially means, there's going to be a PCBA in there most likely, unless it's a very simple product. And a PCBA is basically, the fundamental of any type of electronics. It's the electrical interconnect that connects all the electronic components together. And then once you install all those electronic components, you end up with what we call a PCBA, which is just the assembly. Okay, so when we're talking about the electronic portion of a product, this tends to be the focal point. Okay, now there's other things, of course, right? If you pick up your phone, you're not going to see a PCBA. It's embedded inside, but you're going to see the displays and connectors and buttons and all those things that are associated with it as well. So there are other physical attributes that interconnect into this, but at its heart, typically is a PCB somewhere. Okay, a PCBA is fairly complex. It's something that needs to be engineered. And I'm making this point because you'll see as we evolve through a prototype that somewhere along the way, this needs to be done, and you need to be thinking about it at some point. But it needs to be properly engineered. There's a lot of different complicated interfaces between ICs that need specialized expertise. It also needs to, when you start looking at a PCB design, it needs to be a certain shape, form factor, cost targets, and there's trade-offs all associated with those things. So it's not something that you can just, put together quickly. The other thing is the PCB itself, although it looks fairly, some people might look fairly simple, is also fairly complex and understands, a fairly intimate knowledge of how it's going to be fabricated. So it's even another, specialized set of skills. It's very tightly tied to how it's going to be built, and you need to understand how those fabrication processes impact, its performance and its reliability. All right. So proof of concept. And again, this is very high level, intentionally not going to get into a whole lot of detail here, but here's some boards that some of you guys I'm sure recognize. Raspberry Pi on the left, some Adafruit Feather boards in the center, and then an Arduino Uno on the right. Fairly common boards in the hobbyist space, maker space. Great for building prototypes. These things are absolutely fantastic, and things that we've you go back even 15, 20 years ago didn't exist. Back even 20 years ago when I started out with hardware electronics, the whole hobbyist community was nowhere even close to what it is today. There wasn't a whole lot of tools. There were some development boards that some manufacturers were producing that we were using, in labs at university and things. But actually getting our hands on them as individuals was quite tough. Today, it's very easy, and it's fantastic the issue that we see with it is sometimes people don't know exactly where these should be used and where they shouldn't be used. And that's kind of the theme we're going to get into a little bit here now. So in the proof of concept, these things are absolutely fantastic. Go at it. It's great. Allows you to very quickly build up a proof of concept, even begin with some, very early software and firmware, get things operational, show things how that you could actually build a product and that the components are readily available. That's really the idea here. And we see a lot of these things, happening, obviously, with a lot of the Kickstarter products that we see tend to start with these types of boards. Sometimes, they're even at the stage where they're still using them in a product. We also see a lot of these types of boards being used on, all kinds of hobbyist sites and products that we see out there. So if you look at Hackster and things like that, you'll see tons of these boards being used, which is great. Again, proof of concept. So, if you start looking at what a proof of concept might look like, to me, this is fine. Right, so if you're breadboarding and you got wires hanging out of it everywhere and all that, there's nothing wrong with the proof of concept that looks like this. Okay, but it's pretty rough, right? It's not going to be reliable. You can't put this in a user's hands. That's not the intention, right? So just thinking about it from a hardware perspective, this is okay on a proof of concept. As we move towards a prototype, I'm kind of showing a picture here. These are just a couple of pictures that I kind of stole off Google. Not intended to be anybody's product, and if it happens to be, that's just pure coincidence. But here's another kind of product that's kind of been put together. I have no idea what this thing is. All I see is GPS, so I'm assuming it's some type of GPS-based product. But it's cleaned up a little bit more from a proof of concept, right? Everything's been pretty much connectorized. You're not seeing wires hanging off of different places, but there's no plastics or anything on it. That could be fine depending on the product. But is this the level that you kind of expect for a prototype? Because I do see some creators out there that have things like this when they start to apply for our program. This is typically around where we like to get involved or a little bit further. But, to me, this is still kind of leaning more towards a proof of concept because, and really where the breaking point is for me is that if you put this in a user's hands, you're unlikely to get useful feedback, right? And for one thing, just looking at this is going to kind of create, not a positive reaction, I would say, from your users. So I'm not sure how much value it really has from at a prototyping stage. Still very valuable from a proof of concept. Right, so still, you're still able to demonstrate, its functionality. Looks a little bit cleaner. It's probably going to perform a little bit better, right? So it's great as a proof of concept. I think it still needs to move a little bit further as a prototype. Again, just taking into consideration that you want to get useful feedback from your users. So from a final product, this is the big question I always get, right? And we see this quite commonly as, can I use a hobby board in my final product? So the Raspberry Pi is probably one of the most common ones that we see. Or it could be, an Adafruit with a ESP8266, which is very popular, and ESP32. Can I use those solutions in my final product? It's not a question that is easily answered. It really depends. But I will tell you that, the intent of a lot of those products is not for them to be in final products. And the main reason for that is, for one, I would say the requirements and everything that were put on those boards were not for it to end up in a final product. So things like, environment, right? Being inside, so over a particular temperature range, being inside plastics has some constraints on electronics. These boards were not designed with those things in mind. Connectorization typically presents a problem, right? Most of these boards have some type of connectors coming off them. Connectors are not something you like to have in a product. This kind of tends to surprise some people when they start, looking at early product design. But as an engineer, we avoid connectors like the plague. Connectors tend to be one of the most unreliable things in a product. So as you can tell, it's not just me that that thinks the same thing. You also note that Apple feels the exact same way about connectors and the whole cell phone industry. They tend to put constraints on your product that tends to kind of head down the path of unreliability. So whether it's ingress water or moisture coming into the product, or just usage, right? So most connectors have a limited insertion or mating connections. So usually we want to avoid those connectors, and most of these hobby boards have tons of connectors on them to make them easy to use. So there's a ton of reasons I could go over for not to use them. In some cases, it might make sense. In some cases, it doesn't. But I would say in the majority of them, it does not make sense. And you should be, right from the beginning of your product, considering when you're going to move to a custom assembly or board. Okay. So that's pretty much what I had, for the first 15, 20 minutes here to kind of set up the conversation. There's a whole bunch of other topics that I can discuss and that we can move into, but kind of at this point, I'd love to open it up to you guys. If you've got any questions or any particular direction you want to explore, jump in now would be the time. I'll just give you a few seconds to do that. So are people able to talk now, Kata?
No, I believe, unfortunately, we will either need to use the chat window.
Okay.
And Joel, I see that you have a question listed in there, or votes for the compliancy topic.
Sure.
I do note also, Chris, we've got at least one person who's calling in by phone, and so unfortunately, I don't think they're able to ask questions via chat or the Q&A window. So phone listener, it doesn't identify you by name, but if you would like to participate and you have my email, you can always email me and I'll be your proxy.
Excellent. All right. Yeah. So let's start with compliancy then, since Joel liked to go that way. So this is a fairly broad topic too. I'll kind of narrow it in on, what we see within our program and where a lot of the challenges tend to lie. So from an FCC perspective, pretty much, any product requires some type of FCC or FCC certification. It's more stringent if you are a radiator, so purposefully. So if you have a radio transmitter in your product, whether it's Bluetooth, BLE, Wi-Fi, it tends to complicate the certification. And when I say complicate, that should also translate to dollars, right? Because that just means, there's more testing required, more paperwork that needs to be filed. But, FCC for a Bluetooth product versus a Wi-Fi product can, anywhere from, just to put a price tag on what it would take. If you're starting out with like a chip down solution, you'd be looking at anywhere from $10,000 to $30,000. And I know this is a broad range, but if it's, again, it depends on the complexity, but it tends to be in that range. If your product is not, an intended radiator, it tends to be much cheaper, kind of more in or, sub $10,000, but it really depends again, on the product and exactly, what market it's going into and things like that. But it tends to be much simpler. Trying to think other things around FCC. Modules, that's what I want to touch. So one way to significantly simplify the FCC is to use modules. So if you're if you are going to actually radiate, so you say you're doing a Bluetooth low energy product, this is one area where I see a lot of people do chip down solutions just because they, it's much simpler than doing a chip down solution for Wi-Fi. Using a module can still save you a significant amount of time and effort. When you use a module, the modules are typically pre-certified, which means they've already gone through FCC testing, especially around, how it radiates as a module. When you integrate it in your product, you still have to get it tested. but the testing is significantly different. They basically, the people that are the lab that is doing the testing for you is able to pull up the profile for that particular module, because it was actually tested right by FCC. They're able to pull up that profile, and all they do with your product is check and make sure that the spectrum that's coming out of your product aligns with that module. Okay, which makes it significantly easier. It tends to be mostly a paperwork exercise, so anybody producing the module is able to provide you with their FCC documentation, and with that documentation, you're able to file your application in, and your testing's based on that. Putting a dollar figure on it, it's definitely sub $10,000. It could even be, depending on the module and again what technology, like a Bluetooth product, it can be a few $1,000 bucks. It really just depends. But it does significantly simplify it. So, even with the Bluetooth low energy product where it's pretty easy to do chip down, I still recommend that at least through the prototype phase, use a module. And then at least, if that product is refined enough that you could move into a Kickstarter campaign with it, at least you're moving in with something that's not going to require, a huge investment to get certified. And you can always worry about that certification and the cost reduction that comes along with the chip down solution later, right? Because I guarantee you're going to be looking for tons of ways to save money on the product, especially as you start to hit volume. But through a Kickstarter, typically not that sensitive. I mean, we're only talking about a couple bucks between a module versus a chip down solution. So, it's one way to save some upfront money, is what I would say. Around safety, just jumping back, UL, CSA, most products that we see don't really have a strong requirement around safety or CSA, because most of them are using external adapters, and they're low voltage products internally. So typically you're using some type of external adapter that's going to drop down to 5 volts in most cases. There's a couple products we've come across that might be a little bit higher, but I've been yet to see a product come through the Hardware Studio Connection product that uses direct AC. So being a low voltage product on an adapter, or a wall wart, we tend to call it in industry, basically saves you from having to do the safety compliancy. Okay, so there's other compliancy things like CE and other stuff like that I won't get into here, but that's kind of the, simply put, that's kind of how it falls. The one thing I will mention on the adapters, though, that means you need to carefully select an external adapter that meets all the requirements of the regions you're going to sell into. Okay, so and it's up to you from a liability perspective. So most of the creators we work with are not incorporated, they're not LCCs. They typically tend to be partnerships or individuals. You're actually personally liable to make sure that your product is compliant with all the necessary standards. Okay, so for instance, if you pick an external adapter that off Alibaba that says it's UL or CSA, but it's in fact not, and it catches a person's home on fire, you could be personally liable for that, which is a little scary situation if you think about it. So, my recommendation is don't skimp when you're looking, for an external adapter. What you find on Alibaba and eBay looks very attractive because they're much cheaper than what you're probably going to find through a more official supply of these products. But that's for a reason, right? So these things, typically what you're seeing on Alibaba and eBay are things that you have no idea where they're actually coming from. Anybody can put a CSA stamp or a UL stamp on their product, right? It's not policed. There are no standards police out there, except for the FCC. They tend to police their products a little bit more than anybody else. But when you start looking at safety and things like that, there's nobody out chasing these guys to make sure that that it's official. So it's really up to you to make sure that these things are actually certified. Ask for the paperwork, right? Make sure you protect yourself. All right. hopefully that covers it, Joel. If not, just you could ping me with another question or whatever in around this. But hopefully that's kind of what you're looking for. The paperwork. Yeah, so Joel's just asking, how do we cross-reference the paperwork? So there's a couple things you could do. So if you ask for the paperwork, they should be able to produce it, and they should very willingly produce it. The other advice I would give you is make sure that the paperwork is applicable to that actual part you have. So make sure it explicitly states the part number that you're using, because I have in some cases seen people get paperwork that looks great, but it doesn't reference that exact part number, and in that case it's not applicable. So make sure it references that exact part number, and if you really want to do your research after that and really certify that as real, you can call the standards, and most of them have no problem looking at what paperwork you have and cross-referencing to their database. Now, UL does have an online, or at least it used to have an online database. It's been some time since I've gone in there, where you could actually go in and search the manufacturer and the part number and see whether it's in their database. I don't know if that's still kept up or not. So that's something I have to go look at. But I know there used to be a website for UL anyway where you could do that. But either way, you could send an email, call the standards bodies, and usually they're more than willing to just confirm that things are actually valid. All right. Anybody want to head it in a different direction? If not, I'll kind of pick one of these just to fill in some more time. All right. I want to talk about component lead times a little bit. And particularly, I want to talk about them because I'm seeing some people get significantly impacted by these. So component lead times are basically the amount of time it takes between the time you order, well, by the time a distributor, so an official distributor, places an order on a factory, and the amount of time it takes for that product to actually get manufactured and end up in that distributor's warehouse. So pretty much every electronic component has a lead time associated with it. Sometimes this can be somewhat, I would say, hidden or invisible, because when you deal with some of the catalog distributors like a DigiKey or a Mouser or Newark, these actual distributors tend to have product in inventory, but what you'll notice is they tend to be somewhat lower volume. And really, the intended purpose of these, we call them catalog distributors or e-commerce distributors, is really to service the lower volume business. And they understand that when you're building prototypes and proofs of concept, you need product that's on the shelf. So they tend to keep it in inventory. As you scale to production, what you're going to find is you're going to start to move to more volume-based distributors like an Avnet, where those components are not going to be in inventory, and those actual components need to be manufactured before they're delivered to you. And that's when you become reliant on what we call component lead times. And one area where we're seeing lead times get significantly pushed out, and they have been for some time now, is on passive components, in particular ceramic capacitors. And that's pretty applicable to anybody that's in Hardware Studio Connection. And we're seeing, in some cases, lead times go out beyond a year on some of these ceramic capacitors. And at first, people, I think, didn't get too concerned, because you're still talking about relatively lower volumes, and there still seems to be lots if you just switch the part number. But these days they tend to be drying up everywhere, and we're seeing some customers where they're in a situation where they just can't get capacitors for the next 52 weeks. They're just physically not going to get them. That can have a substantial impact on your schedule and your financial situation. So it's one, it's an area where you really need to be careful. A lot of the times with Hardware Studio Connection participants, or when we're evaluating people to come into the program, we spend a lot of time talking about schedules, And you know, one of the things that we're kind of sensitive to is when, you know, schedules are extremely aggressive and they tend to ignore details like lead times, right? So people are kind of just looking at how long it's going to take them, you know, to manufacture a product, or how long they think it's going to take to, you know, to bring a CM on board, and then they figure, oh, 8 weeks after that they'll be good. You know, you need to understand that there's some things that are just beyond your CM's control, and this is one of them. So it's something you really need to stay on top of, and you know, you should, on a regular basis, you should be getting your BOMs quoted, so that you're able to get visibility of these lead times. And of course, this is mostly important, you know, as you start to move into a production type scenario, right? If you're building hundreds, then typically, yeah, you're probably going to find it in inventory. But if you're building thousands, it's unlikely you're going to find it in inventory. And you know, getting caught in one of these situations where lead times are extended can be very difficult. And being you know, a small customer, or at least a relatively small customer, you know, really doesn't give you much leverage at all, and you're basically stood, you know, you're in line just like everybody else, and it can be a very tough situation. So I just wanted to point that out, and this is for all components. I mean, this is, I know some people tend to think that it's, you know, just for electronics, but you'll see this on, you know, all kinds of passives and discrete components, panels, everything. So you're always going to be subjective to these lead times. And the other time where it can really bite you, I mean, on the ceramic caps, the excuse that I hear from most manufacturers is that the automotive industry is causing the shortage. But there's all kinds of things that cause shortages. You know, you look at natural disasters and things, and some of the areas where these things are manufactured can have huge impacts on lead times, and you never know when one of those are going to bite you. So it's just one of those things that I wanted to point out. It's just one of those things that can really get you. You know, Joel, just what can we do to avoid it? It's really just, you know, if it's a couple things. One thing that I look for as we start to move into production, and when I start looking at some of your guys' BOMs, is I'm looking to make sure that the components that you're using are not some obscure type component that I feel nobody else is using, or it's made by one manufacturer over in Taiwan. It's important to avoid those things as much as possible. So, you know, things that are single source. So really, what I mean, that's the best way to avoid it, is to make sure that the components you're using are you know, widely available, and is not something that's unique to you or just a couple customers. That's probably the best one. After that, it's really, you know, when you start looking at, you know, things that are getting influenced by industry trends, it's, you know, making sure that you're getting your BOMs quoted regularly, right? So send them to a distributor, send them into Avnet, right? We're happy to quote. We do it all day long, right? So, you know, send in your BOMs to us. We'd be happy to quote them, and in that quote, you know, we do look at lead times as one of the key things that we do look at, and how available a product is. So that'll give you some he asked, you know, what do I consider regularly? Regularly, I would say every 30 to 60 days is what I would suggest. You know, if there's something that you're particularly concerned about, then you might want to do it 30 days. Might not be your whole BOM, but maybe just a couple components. And then, you know, your whole BOM, 60 days is not crazy. You know, just to give you some insight. And, you know, if you do see something that is of concern, there's things that you can do. I mean, you can purchase parts, right? So in the case of ceramic capacitors, you know, you can buy a reel of parts for $100, and it can keep you out of a lot of trouble. You know, if you have the financial means to do that. In some cases, I mean, as you get into production and a more, you know, what I would call a, you know, medium scale customer to a distributor, in many cases they'd be willing to put inventory on the shelf for you, and there's different models that would fit into. And, you know, in a future one of these webinars, I'm sure we're going to have a supply chain type discussion, and in there we'll get into some, you know, some more details around how distributors do that. But there are, you know, when you start looking at, you know, production-based scenarios, that's where a lot of the large distributors like Avnet shine, because we're able to put supply chain models in place that keeps you out of trouble when it comes to things like lead times, or, you know, things associated with natural disasters, those types of things. Okay, but it's more got to do with how we flow product through and how we warehouse product. But there needs to, for us to do that, we need obviously it costs money, and so there needs to be somewhat at least some ongoing business that's occurring. Okay, hopefully that answers a couple things there, Joel. It kind of leads into another thing, which I'm going to jump ahead on a few of these other bullets. It kind of ties in a lot into component life cycle and the end of life as well. So, and this is another one that will get you, and this is just one of those things you got to live with when you start looking at hardware design. Components have a very defined life cycle. Trying to predict it can be very, very difficult. But if it's a consumer type component, so say, I don't know, let me pick one, like an ARM core that goes in a phone. So like an ARM microprocessor, memory is very susceptible to this, especially flash. Those components tend to have very short life cycles. And when I say short, like 3 to 5 years is not uncommon. And essentially what happens is these manufacturers are constantly looking at what the demand is for components, and based on that demand, adjusting production and manufacturing. And in many cases, it'll get to the point in the life cycle where there's, the demand is minimal and they will end of life it. So they'll discontinue the manufacturing of that product. Very common with consumer-oriented products. Some of the products that, when you start looking at that we see go through Kickstarter, tend to have a little bit longer design cycles, because in many cases these companies are not well established, not well experienced right through product design, so it tends to take a little bit longer. And you've also got to develop marketing and distribution. So what we find is you can run into these types of situations very quickly, sometimes just as you're entering production. So it's one thing you got to be aware of, that even though you've completed design on a product, there's also what we call sustaining, right? And part of that sustaining is dealing with what we call obsolescence issues or component life cycle issues. And so, throughout the product's life, you're going to continuously be updating the hardware design. That's just one of the things you're going to have to live with, and it should be something that you should be building into your business models, because this is going to happen. Just recently, we were working with a creator or more of a startup company actually, that were not necessarily in the program, but on the peripheral list program. They were helping out with some things, and they were pretty much headed right into production. They're picking a CM, everything. And they found out that the display they're using, and if I'm not correct, I think they used several of the displays in the product, was actually end of life. And they, basically couldn't buy the product anymore. And the thing with displays, if you're using one, what you'll notice is that they're, second sourcing displays is very difficult. They don't tend to have, common form factors. They tend to be a little bit specialized. Characterization tends to be very specific to the product. So they're very tough to find somebody else that makes the exact same thing. So they were, they had themselves in a very difficult situation, trying to now very quickly switch to another manufacturer, to another display, and that was going to impact, their overall product design, just as they were going to move into production. So it's one of those things you got to watch. Myself, I just recently worked with a startup, doing some work intimately. And one of the components that I suggested for them, and we actually put in the design, actually went end of life as they were moving through the prototype phase. There was no, I did all my homework. I did everything I should have did to try to see what the life cycle looked like. But for whatever reason, this particular manufacturer decided they were going to end the life the part. So it can blindside you even when you do the homework. One of the things I kind of offer up as a free service to many of you guys, as you come into this Hardware Studio Connection program, when you got a BOM, I'm more than happy to put it through some of the tools that we use at Avnet that looks at the component life cycle. I can tell when the part was actually, when it entered the market, whether it's a more consumer-oriented or an industrial-oriented product, and it tends to give me projections on lifetime. They're not 100%, but it will make some guesses based on the demand and things for the product, and it will also flag products if they are, not recommended for new designs. Is typically the stage they go into first, which is usually about 6 to 9 months from an end of life. So a lot of those things get flagged in our system, and hopefully we can pick them up. But like I say, it's not 100%. But it's just, again, one of those things that you got to consider as you start to move through a hardware-based product. Yeah. So what comes out? It was slipping my mind. And Joel just asked, are there any notifications from manufacturers that a part will be discontinued in the future? And yes, there is. It's how they get to you that's the problem. So they do tend to post them on their websites. They do post them to all the franchise distributors are notified. So there's an official process that a manufacturer goes through when they end the life of product. The problem is if we're selling that product to you on an ongoing basis, then we will notify you. So like as Avnet, if we're your distributor and you're an established customer with us, then you will get that notification from us. But if you're not, so like if you're ordering from a DigiKey or you're ordering from us, but more just in an e-commerce type basis, then you won't get it. And you've kind of got to go looking for these things on your own. So either you're hitting websites looking for them, or like you say, you can pass it on to me and I'll do a scrub through it and just see if there's anything flagging in our system. But yeah, there's an official end of life process. So usually associated with an end of life is what we call last time buy. So that's part of the notification. So that notification will basically say, there's going to be, we're end of lifing the part, and there's a last time buy, typically about 6 to 9 months out, which means that after that last time buy date, you can no longer place orders on the part. Okay, but again, there's things that distributors can do for you if you're an established customer, like doing bulk orders against parts and things like that too. With that last time buy, that gives you an opportunity. So say it is a screen, a display in your product. Obviously, switching out is not easy, but giving you a 6 months warning, that allows you to at least forecast what you think you will consume and build a kind of a buffer out so that you're able to replace that part with something else. That's the intent, but it can be tough getting them, the notices. Like in this case, like I say, I was intimate with it and I was kind of tracking it and I still missed it. And it never got sent to me. So, sometimes they will pass you by and you can't notice them. So it's something you got to be, somewhat diligent with, especially on your key components, right? So like displays is a big one. Or if you got flash in your product, you want to track that stuff very carefully, looking for end of lives. Yeah, so throughout the lifespan of the product, Joel is asking, should we be quoting BOMs in that 30, 60 days throughout the lifespan of the product? I'd recommend it. 60 days, typically your pricing, is good for 30 days when you get a quote. So, typically you're going to be quoting every 60 to 90 at the most. And if you're working through a CM, they're going to be doing this on their own. But yeah, if you're doing all this on your own, the manufacturing and everything, then I'd definitely recommend every 30 to 60 days for sure. And a lot of these things then will get flagged. And so if you do have something that does go end of life, you're going to be notified and you'll have, lots of time to respond to it. All right. Anything else, Joel? I'll give you the last crack at it. We're starting to wind down here. I don't know if I want to move into any of these unless you want me to go in a specific direction. All right. Anything else here I want to go down that I think is, I think we'll probably leave it there, Kata. And if somebody has any questions or anything afterwards and wants to pick one of these for me to go into at, into more detail at some time, batteries is kind of a hot topic with a lot of people. just sourcing batteries, different types of batteries, design concerns with batteries, shipping batteries. There's all kinds of things around batteries. So that we could get into, and maybe it might be a good topic for the future. I notice Joel's just talking about batteries now, like sourcing batteries. I'll just lightly touch it. Is another one that can be somewhat difficult. So batteries, even though it looks like an electronic product, it's not your traditional electronic product. So for distributors like Avnet, batteries have many challenges. For one, they have a very short, or at least relatively short shelf life. They also need to be charged regularly, so there's maintenance issues involved with them, and there's shipping constraints. So what you'll find is most of the large distributors, even the small ones like a DigiKey, you're going to see that like lithium polymer and lithium ion batteries, not a whole lot of offering, and it's for those exact reasons. So batteries can be somewhat difficult to source, and what you'll find is batteries come from predominantly from their manufacturers directly, which presents some problems for us in North America since most of the batteries are manufactured in Asia. So there's a couple what I would call small distributors for batteries here in North America. You're welcome to use those to source some, but you're going to find that the cost is high. So what I find with lithium ion and lithium polymer, you're forced to pick some type of Asian source. And in doing that, what I'd recommend, prior to going into production, either yourself or have a company represent you to go in and audit that company and make sure that it's actually reputable. That's I know it's not nice, it's not clean, but that's typically what I see happen is you're kind of forced down that path. If you're looking at battery packs, so if you have a product where it's looking for something a little bit more exotic, there's lots of companies in North America that tend to do pack based products. Okay, and there's a lot of little specialty things that are involved in doing packs. So if you're stacking lithium polymers or things like that, there's all kinds of protection devices that need to go in there, and usually you've got to get what we call a battery integrator involved, and you'll find lots of those on the web, and that's a good start for those types of products. So like if you're doing some type of power tool product, for instance, those batteries tend to come through battery integrators that specialize in those technologies. That's as much as I'll talk about it now, because we could do a full hour on batteries. But okay.
Great. Oh, thank you all for joining us. The next session is on Valentine's Day, easy to remember, on February 14th. I believe it's at the same time, but I'll be sending out email reminders. The topic of that webinar will be quality considerations, specifically geared towards companies who will be launching on Kickstarter, but kind of the basics and building blocks behind what you should be considering pre-Kickstarter campaign and as you move through that campaign on the quality front of manufacturing. So that will be Spencer Hartfield from Dragon's Boston team. So we will talk to you all then, and as always, feel free to send over any questions by email in the interim, and thanks so much for joining us today.
All right. Thanks, guys.
All right.